Hello, I am Amy Tao, and we are in a group with Parker Callender, Ethan Frona, Sanam Javeri, Justin Grudem, and Sammy Gelade. And today we are presenting a 3D printed canine dental device for Class 2 malocclusions. And now onto our abstract. A Class 2 malocclusion in dogs is often treated with orthodontic brace devices that are called incline planes. Incline planes can move teeth through passive force and can be created through several different methods, including 3D printing. However, the current design and workflow of the 3D printing incline plane is very complex, and there's a need for a more adjustable, flexible design. To tackle these problems, the team has devised an alternative design consisting of two 3D printed pieces for each side of the mouth, which allows for growth of the maxillae and decreases risk of palatitis. Additionally, the software Blender for Dental was used to fit the piece to the jaw and manipulate the teeth and the piece. For our group's motivations, malocclusions are heritable traits that can cause issues for dogs and cats if not treated. And this treatment process can involve many different complications, such as adjustments that may be needed throughout the process, or side effects such as gingivitis and palatitis. Additionally, 3D printed has been adopted into human dentistry, but it is not as common in veterinary dentistry. Therefore, the project's goals are to improve treatment for patients and streamline the fabrication and treatment processes for veterinarians and veterinary orthodontists alike. And now on to Sammy, who will talk about background information.
Thanks, Amy. A malocclusion in dogs is a misalignment of three important teeth: the maxillary or upper canine, the mandibular or lower canine, and the third incisor of the upper jaw. In image 1, you can see what the normal alignment of the teeth should be, where the lower canine fits between the upper canine and the third incisor. In Class 2 malocclusions, the lower canine is pointed inward, which results in the teeth hitting the upper palate, which causes pain, damage, and infections. This can be shown in images 2 and 3. These are currently treated most commonly by extracting the teeth or shortening the lower canines. In some cases, more recently, orthodontics can be used to rotate the teeth outward. The previous design for the one-piece incline plane is shown in image 4. Next, I'm going to be talking about the design criteria. For the physical design, the piece must be able to withstand up to 400 pounds of pressure from the dog's bite. In addition, the device should last the entire treatment period, which is usually around 6 to 8 weeks. For the software portion of the project, our goals are to have the interface easy to understand, as well as be able to manipulate the model of the jaw in order to get the desired rotation of the incline plane and teeth. Next, Ethan is going to be talking about the software.
Thanks, Sammy. Over the course of the design project, we evaluated 7 different softwares for their ease of use and relevance to our project, including softwares such as 3D Slicer and Geomagic for SolidWorks. However, our team decided to go with the software Blender, which is a free software made for 3D modeling and animation. Using Blender, we uploaded the DICOM and CT files given to us by our client to visualize how all of these components align in a 3D space, as seen in Figure 7. The original piece was loaded in and manipulated to fit over the upper canines of the jaw model in order to make sure the dimensions of each of the models and the files matched with each other. Using the animation software found on Blender, we were able to visualize how the lower canines respond to treatment by the device, as seen in this video here. This movement is made possible by the incline planes found in our design. The planes cause the teeth to shift along their vertical axis by an angle of around 30 degrees for around a period of 6 to 8 weeks, depending on the severity of the malocclusion. An axial force is studied to apply to the lower canine over that period of time, which causes the tooth to shift towards its horizontal axis. The software also has splicing and editing tools, so the team can change the dimensions of the piece to better fit the models as seen. There are a variety of these tools, such as the scaling tool, which allow the model or a specified section of the model to increase or decrease in size. While Blender does have splicing tools, they are generally used for more geometrically simple objects, not complex STL files. To create the final design, a secondary software called Mesh Mixer was applied to cut the file in half so we could have two separate orthodontic pieces, which Justin will explain in our final design.
So like Ethan said, we were able to use the software Mesh Mixer to slice our inclined plane into two separate pieces. Each side of the device still includes 3 teeth holes for the upper maxillary, canine, and incisor teeth of the dog, as well as a ramp to push the lower canine teeth into the correct position of the mouth. Having a 2-piece device separates each side of the malocclusion into its own unique situation, which allows for greater individual manipulation of each of the 2 lower canine teeth. Another key feature of the final design is the absence of a bridge connecting the 2 pieces of the device. One of the main problems our client was dealing with was altering the width of the device to fit many various mouth sizes. By eliminating the bridge, we were able to tackle this problem. Another problem that the separated device solves is the irritation that the dogs experienced in the upper palate due to the presence of a bridge. We were able to print the device using dental LT resin, which was already proved to work effectively in the original device. Now I'll pass on to Sunny, who will talk about our testing process in SolidWorks.
Thanks, Justin. So using our design in SolidWorks testing, we were able to confirm that the product could withstand the bite of a canine. Force points of 1,350 newtons were applied to the device to simulate a canine's bite. Overall, the test results were really good and showed the durability of the product. The small red areas in figure 11 would experience a stress concentration of a value past the device's yield strength and would result in a deformation of about 0.8316 millimeters. However, this is not a significant amount in terms of the whole product. Aside from that, the rest of the product was able to withstand the force and stay structurally sound. With the success of the 2-piece product, we are now able to look at how our design can be applied to multiple different types of malocclusions, class 2 malocclusions in different canines. So now Parker is going to talk about this potential future work for our project.
Thanks, Sunny. As mentioned, this medical treatment is in very early stages as the doctor has actually only performed it on 1 patient. Therefore, if the team were to continue the work further, the team would want to implement what has been discovered in new patients. In other words, we'd like to be able to see a CT scan of a new patient or new dog and be able to build this work from the ground up for that dog in specific. Therefore, we could then develop a particular incline plane to fit the mouth and specifications of the new dog. And going along with that, testing of these braces as the patient progresses through therapy would be much more accurate and have many more variables in order to understand where we're going wrong, where we can go better for the future. Additionally, we would use Blender to manipulate current designs, could use Blender to manipulate current designs, or instead of creating a completely new one from a CT scan and seeing if it would be possible between the same type of dog if we could just manipulate certain variables instead of building a completely different one. Last, we just wanted to say thank you so much to our client, Dr. Graham Thatcher, as well as our advisor, Dr. Walter Block, for guiding us through the design process, providing valuable advice, and overall creating a positive experience where we as students could learn and apply our knowledge from our classes. Thank you.